Thank you, and good morning. This presentation will cover riparian stands, buffer tree mortality, and large wood recruitment to the stream. And I'll be presenting data up to the first 2 years after harvest, and this is preliminary data. And I'd like to start by acknowledging my co-authors, Ash Rohrbach and Greg Stewart, and the many hardy field workers who assisted with the field effort. So the HCP aquatic strategy is designed to provide protection for fish, amphibians, and water quality. And the riparian forests are really critical to achieving these objectives because they provide important functions like shade, wood, and litterfall. So the HCP uses a riparian buffering strategy that's intended to maintain and improve these riparian functions over time in order to achieve these resource objectives. The purposes of the riparian component of this study was twofold. First, we wanted to document the magnitude of change in riparian stand conditions and buffer tree mortality rates. And then we also wanted to provide context for interpreting other responses that are influenced by the riparian stands. Our sampling strategy focused on the riparian management zones, or RMZs, which on the type end streams are a band along the stream that extends out 50 feet on both sides. So our RMZ sampling plots were 50 feet in length along the stream and extended out to the edge of the RMZ on both sides of the stream. They were laid out in a systematic fashion from a random starting point, and in the small basins we sampled approximately 50% of the stream length and 33% in the larger basins. Oops, let's see, got to talk about PIPs. We also sampled perennial initiation points, or PIPs, which are a special sensitive site that receives a 56-foot circular buffer that's centered around the uppermost point of perennial flow. And for the PIPs, we took a random sample from each of the treatment groups. To document the changes in riparian stand conditions, we measured the live and dead trees in our plots, and then we calculated the stand density and the basal area per acre. We documented buffer tree mortality by recording the trees that died between our surveys, and then we calculated the mortality rates in terms of trees per acre per year and basal area per acre per year. And we documented large wood recruitment to the stream by measuring the portions of fallen trees that fell into or over the bankfull channel. And then we calculated a piece count and a volume. We used data from 3 surveys to document conditions before and after harvest. The first survey took place in the summer of 2007, which was 1 year before harvest. The second survey was in the summer of 2008, which was immediately before harvest. And then the final survey was in the summer of 2010, which was 2 summers after harvest. The 2007 data were used to characterize the initial stand conditions immediately after harvest, and then we compared the 2007 and the 2008 surveys to document changes during the pre-harvest period, especially to document the effects of that intense windstorm with hurricane force winds that affected the coastal areas of southwest Washington the winter between the 2 pre-harvest surveys. And we documented the magnitude of change by compare the magnitude of post-harvest change by comparing the 2008 and the 2010 surveys. And then we used a general linear mixed effects model to do a statistical comparison among the treatments and the reference sites. And the response variables that we used in that analysis were stand condition changes, particularly live basal area per acre, tree mortality rates, and large wood recruitment rates. So the initial riparian stand conditions at the start of the study were similar in 4 out of our 5 blocks, and they consisted of dense second growth conifer-dominated stands with between 150 and 300 square feet of basal area per acre. However, there was a notable difference in the South Cascade block where we had a much higher proportion of broadleaf trees, particularly alder, and generally lower stocking levels in the 50 to 200 square foot range. So while we often think of these second growth stands in Western Washington as being rather homogeneous, there are some sites out there that are quite different, which could affect their response to our riparian management practices. Well, this graph shows the mean percentage of buffer tree mortality for each site during the pre-harvest period. So we have the percent mortality in basal area per acre per year over on the y-axis. And then we've got the different blocks with their RMZ and PIP sites kind of arrayed along the x-axis here. During the pre-harvest period, the mortality rates were real low in the Cascade block, the Olympic block, and the Willapa 3 block. But in contrast, the mortality rates were highly variable with some much higher values in the Willapa 1 and Willapa 2 blocks, which were those coastal blocks that were affected by that December 2000 windstorm. However, even in the blocks with the high mortality rates, many of the individual plots had mortality rates which were less than 10%. So we found that the mortality from wind damage was really inconsistent, and there was a lot of variability within the sites. Well, this slide shows post-harvest site mean mortality rates by treatment. So we've got a graph for RMZs and a graph for PIPs. We've got the percentage of mortality in basal area per acre per year on the y-axis. And then we have our treatments across the x-axis. So we have the reference sites, the 100% treatment sites where the stream network was totally buffered. And then we have the buffered portions of the forest practices sites. And the sites are color-coded by the block that they were in. So for the RMZs, you can see that there was a fairly similar pattern for the reference and the 100% treatment sites. But the forest practice buffers had a lot more variability and some much higher values. In the PIPs, there was more evidence of a gradient in response with the lowest values and the least variability in the reference sites, more variability and higher values in the 100%, and then the highest values in the forest practice buffered sites. The table shows the p-values for the treatment comparisons. So for the 100% versus the reference comparison, there was a significant difference for the PIPs, but interestingly not for the RMZs. The forest practice buffered versus reference comparison, we saw a significant difference for both RMZs and PIPs. And then for the forest practice buffered versus 100% buffer comparison, there was some evidence of a difference, but the evidence was really weaker for that one. These figures show the change in basal area per acre during the post-harvest period. So again, we've got a graph for, sorry, wrong button. Got to get back here to the right one there, sorry. So we have a graph for RMZs and PIPs, and this is the change in basal area per acre on the y-axis, and we have the treatments across the x-axis. And in this plot, the yellow line is the zero line, or no change. So any points above that line increased in basal area per acre, and the points below the line decreased there. So nearly all our sites showed a decrease in live basal area per acre during the 2-year period after harvest, which indicated that mortality exceeded growth during this period. The graph for the RMZs shows some evidence of a gradient there with the least variability and the least amount of change for the references, somewhat more for the 100% basin, and then we see the greatest decrease for the forest practice buffers, except for the 0% treatment where the RMZs were harvested. And the pattern is really similar for the PIPs. So this figure shows a snapshot of the riparian stand conditions 2 years after harvest. So in this one, we have the live basal area per acre on the y-axis and our reference, or our different treatments across the x-axis. And here you can see those post-harvest stand conditions are rather similar for the reference and the 100% treatment sites. And then we've got a lower values in our forest practice buffers, and of course the lowest values in the clear-cut 0% basins. And a very similar pattern in the PIPs. This slide also shows the post-harvest stand conditions, but now we're looking at the plot level for the various treatments 2 years after harvest. So in this one, sorry, I went one too many here. There we go. So in this one, we've got the percentage of plots on the y-axis, and then categories of basal area per acre across the x-axis going from 0 to 400. And the bars are color-coded by treatment. So the reference sites are green, the 100% treatment plots are blue, and you can see that they have a very similar distribution there, kind of a bell-shaped curve with most of the values between 100 and 300, and probably a peak around 200. In contrast, when we look at the 0% treatment in yellow, which were the ones that were clear-cut, you can see that the majority of the plots there had no trees or very little in the way of trees. But I think the most interesting distribution is actually for our forest practice treatment, which is shown in pink. And this treatment represents the current rules. And remember, it's a partial buffering strategy, so you can see that 40% of the plots were clear-cut. And remember, all these clear-cut plots will be replanted under the rules. But then for the buffered plots, there's a peak there at about 100 to 150 square feet of basal area, and then some small tails going off in both directions. So the distribution of the plot values for the forest practice buffers is quite different for the 100% or the reference buffers there. You can see the distribution's really shifted to the left. And that reflects that increased mortality that we saw during the post-harvest period. This graph shows post-harvest large woody debris recruitment volume. So that's the volume in or over the channel for the first 2 years after harvest. And there we have the volume in cubic feet per acre per year on the y-axis. And we've got the treatments on the x-axis. In the RMZs, you can see that the recruitment rates were relatively low and fairly consistent for the reference sites. But then for both the buffer treatments, we just had a tremendous amount of variability with some very high levels. And there was kind of a similar pattern for the PIPs there, but a little less extreme. So basically this indicates that some of those buffer sites provided a lot of wood recruitment in the first 2 years after harvest, and this was due to the wind throw. Interesting to note, though, that the majority of those recruited pieces, about 75%, actually were initially spanning or suspended over the channel. So consequently, the percentage of pieces that provided in-channel hydraulic functions was quite limited. However, those spanning and suspended pieces do provide shade and cover, and we also expect that they will drop into the channel over time as they decay and break up. This slide compares post-harvest buffer tree mortality rates documented in the Hard Rock study, with other studies of type N streams in western Washington. And here, ooh, that looks kind of nasty. But anyway, there's a table for RMZs and then a table here for the PIPs. And the first column shows the mean percentage of mortality. This column is the range of values, and then this column shows the years after harvest. The rows for the reference sites in this study are shown in white. The 100% treatment sites are shown in green. And then the yellow highlights different studies that looked at the current forest practice buffers. So we have the Seamer's BCIF, or Buffer Characteristics, Intensity, and Function study. We have this study's forest practice buffer sites, and then we've got a study by Jackson et al. So for the RMZs, you can see that the lowest mean mortality was in the reference sites, and then we had somewhat higher values, about 17% for the 100% basin sites in this study. And then we had a range of values for the current forest practice rules that went from about 20% for the BCIF study, 30% for this study, and then 47% for the Jackson et al. Study. And for the PIPs, the values ranged from about 7% for the reference, 20% for the 100% treatment, and then for the current rules, we were at 35% for the BCIF study and 47% for the forest practice buffered PIPs in this study. So, in conclusion, as Mark had mentioned earlier, we definitely found evidence of a treatment effect for tree mortality, for changes in stand condition, and for large wood recruitment. For tree mortality and the changes in stand condition, there was evidence of a gradient effect in the response that corresponded with the treatment intensity. So we had the least amount of change and response in the reference sites, and then a greater response in the 100% treatment sites, and the greatest response in the forest practice treatment sites. One thing that was interesting was that for these metrics, the 100% treatment sites were more similar to the reference sites than they were to the forest practice buffers, even though both of those used buffers that were 50 feet in width, and the main difference there was just the proportion of the stream network that was buffered. So that concludes this presentation, but I would like to just have you bear in mind that these are short-term results for the first 2 years after harvest. As Amy mentioned, the study's continuing, so we will be tracking the disturbance and recovery of the riparian stands and their functions over time, and hope to provide a longer-term perspective in our future talks. So thank you.